Hey calculus students, it's me, Ms. Culver. I know it's hard to tell because I don't have makeup on, not much. And this is my real hair. There's a lot of it. Welcome to my lovely living room. Here is my setup with my whiteboard. I hope that this works for you. We're going to be doing sections 6.2b and 6.3 today because they should be together, so we're going to put them together. It's solving differential equations using separation of variables. Here are the steps. I will also be asking you, the last thing we did together, miss you all so much, was 6.2a, and I will be asking on Google Classroom what problems you need to see from that section, and I will shoot another video of doing those problems if you need any of those. So let's read the steps. The connection between x and dx and y and dy is multiplication. So any addition or subtraction to separate the variables must be done first, followed by attaching the dx or dy through multiplication. That doesn't mean much until we actually start doing it and you see what I mean by that. Number two, we're going to isolate the output variable, usually y. It is in each of these cases, so that when we integrate, we have the y alone as much as possible. Number three, the text mainly writes final functions without denominators and with variables on the left and the constant on the right. You don't have to do that. Sometimes they do on the AP exam, sometimes they don't, but we'll do it the way the book does so you're used to it and you can check your answers more easily. So let's get started. Example number one. Given y prime equals a negative 9x divided by 16y, and they give you 1, 1, write the function y equals. Now what we're going to do, when you look at number 4 here, change y prime to dy dx so you can separate. Notice we have x's and y's in this function here. We do need to separate those, so we are going to write our y prime as dy dx so we can separate those variables of integration also. So the first thing I'm going to do is simply write y prime as dy over dx. Okay, let's go to the next step now. The next step is I do want the y's on the left and the x's on the right. And so I am first going to multiply each side by y. There we go, so that these y's cancel. And let's write what we have now. On the left, we have y times dy dx equals negative 9x over 16, or negative 9/16x. Notice I did not bring the 16 over with the y. I want as little with the y as possible. Now, I have the x's and the y's separate. I have to multiply both sides by dx so that the correct variable of integration is with the correct variable. So we have y dy equals negative 9/16 x dx. Okay, let's go ahead and integrate. Notice when we integrate on the left, we have y squared over 2. When we integrate on the right, that will become an x squared divided by 2 multiplied by the negative 9/16. So to save room, I am assuming you would be able to show that the squared is on the x and the dividing by 2 would now have a 32 in the denominator. And let's not forget our plus c. Why is there not a plus c on both sides? Because if I had a plus c on both sides and I subtracted 1 from both sides, it would just still leave a constant on one side. We will make it on the right. The next thing I'm going to do is solve for c by putting in the 1 for the y and the 1 for the x. So let's go ahead and get that. I'm gonna have to go a little lower here. That would be 1/2 on the left equals -9 over 32 plus c. Notice what I can do is make this 1/2 as 16 over 32. And I'm going to add the 9 over 32 to both sides. So that would be 25 over 32 equals c. So let's go ahead and write the equation that we have now. Right now we have y squared over 2 equals -9x squared over 32 plus 25 over 32. Now this is perfectly correct, but here's what the book will do. They will go through and multiply everything by 32 to get rid of the denominator, and they will also move all the variables to the left and leave the constant on the right. So let's go ahead and do that in one step. I'm going to multiply by 32, and I'm also going to move the x squareds to the left. Here we go. Let's see, that would be a 16y squared. When I multiply by 32, that would be a plus 9x squared when I multiply by 32 and move it, and that would equal 25. And here is your final answer. All right, class, let's go to number 2. Solve dy over dx equals 6 minus y. Class, this looks super easy. It is not. We have to be so careful here. Here we go. Here's what I want you to know. We cannot add a y so that the y is with the variable of integration dy. We cannot do that. That is not the connection between y and dy. We cannot add a y. What we have to do though is we do need the y's on the left. So I am going to divide both sides by 6 minus y. So on the left, I have 1 over 6 minus y, dividing both sides. Okay, the 6 minus y is now gone. On the right, so I have a 1 there. I divided both sides. Notice on the left I wrote dy. I'm going to, at the same time, to save room, multiply both sides of the equation by dx. So let's take a look at that again. I can't add a y to both sides, so I divided both sides by 6 minus y. I now have the variable of integration. Sorry, my brother's coming up the stairs. And
hello there.
Well, hi, brother. How are you?
Wonderful.
It's my brother, Doug. So, and we kept the dy with the correct variables, and we multiplied both sides by dx. So now the variables are separated. Okay, let's integrate both sides. Okay, I think I'll be real good on the right here, but on the left, I feel I need a u substitution. I think I have a natural log situation. We have to check though. Again, watch really closely. This gets a little tricky. On the left, let's make our u 6 minus y. That makes our du a negative on the y dy. Notice I don't see a negative here, and so I am going to multiply both sides by a negative. Let's go ahead and do our substitution on the left and integrate on the right because we know what we're doing. Here we go. On the left, here's my 1 over u. My dy is a negative du. I'm going to go ahead and integrate on the right, and that will be an x plus c. Okay, on the left, we know how to integrate this. This would be a negative natural log of the absolute value of u. So if it's okay with you, I'm going to go ahead and do that, but where I have the u, I'll put the 6 minus y back in. There we go. Again, the natural log of the absolute value of u, my u is 6 minus y. Okay, I need to solve for the y. Normally I would exponentiate both sides, raise it to a base of e so that the natural log cancels. I can't do that right now because the negative is in the way. I am going to move this negative using the power property of logarithms as the exponent of the solution. Okay, this gets a little crazy here. Here we go. Now we can exponentiate both sides with a base of e. Okay, watch this carefully. E and the natural log cancel out. The absolute value also cancels because e to anything will automatically make the solution positive. But I do have this exponent of a negative 1. Let's not lose that. Okay, on the right, notice that this whole exponent, I can write this expression as e to the x times e to the c, right? Because that would cause me to add those exponents. And e to the c is just a constant. Okay, we're almost there. My brother's looking at what the heck is going on this board.
Just checking your phone.
How's it looking?
It's turned off.
Is it turned off?
Yeah.
Is it really?
No.
Oh, you are awful. Isn't he awful? Okay. Oh my gosh, that would have been a lot of work for nothing. Okay, so what we have to do to get rid of the negative 1 exponent is multiply, raise both sides to the negative 1. All right, we are getting there. I'm going to have to come on down here again. Let me use a different color. Okay. We have 6 minus y now equals. Now, notice c to the negative 1 is still a c. But e to the x to the negative 1 is e to the negative x. I'm going to write that in this way. I am going to subtract a 6 from both sides. And now, thank goodness, I just need to get rid of the negative on the y. So we're way down here. I'm going to go through and multiply each term by a negative. And this is your final answer. Crazy math. Now, I'm trying to get up. It's hard when you're older. There we go. The great thing about doing this at home is now you can stop and keep watching it over to see the little pieces, what happened there. Let's do the last problem. It's actually easier. Now my brother's got me paranoid. I'm gonna check and make sure this is still going. It is. All right. Number 3, write a differential equation for the rate of change of y with respect to x is proportional to the difference between x and 4 and describe the slope field. Okay, so the rate of change of y with respect to x is proportional to the difference between x and 4. And describe the slope field. Notice here's the slope here, and if I drew a slope field, there's some things I would see. notice that we don't know what the constant is, so that would change your slopes depending on what that K is, but there's some things we can say. Notice wherever x equals 4 that the slope is 0. Notice wherever x is less than 4 that the slope is negative. Notice wherever x is greater than 4 that the slope will be positive. Ta-da, there we go. All right, thanks for joining me in my home. I'm gonna take the camera now. Hello, let's turn this around. And let's see if we can find the kitty. Oh my goodness, there she is. There's Princess. Look folks, this is a lot of cat. Isn't she beautiful? Hi Princess. Hi Princess. Thanks for joining me today, class. I hope you're all doing great.